Cardiovascular responses. The cardiovascular responses consist of the equation in order to determine cardiac output. As well as this, the cardiovascular system is made up of different components. These consist of the organs and the muscles, as well as the cardiovascular response center, as well as the different receptors which send these responses to the control center. These help to determine whether any changes in the CV system need to occur at any current moment. Cardiac dynamics. Firstly, the cardiac system will respond to a warm-up by slightly increasing heart rate and stroke volume even though the body is only working submaximally. This happens because during a warm-up your body is working more than you would be if you were not exercising. Therefore the blood needs to be pumped around the body faster to supply all the working muscles with oxygen more, despite the fact that they are still not intensely working. Also, this is known as a warm-up, as this increase in heart rate and stroke volume tends to warm up the muscles and prepare them for exercise, as well as making them more elastic and flexible. Similarly to ventilation, in respiration, the cardiac output, which is known as Q, has the equation of two factors adding together to make this one. For example, heart rate is the amount of beats your heart does per minute. This is measured in BPM. Stroke volume is the amount of blood pumped by the left ventricle of the heart in one contraction, and this is recorded in milliliters. Both of these factors contribute together to make up a person's cardiac output, and all of these values are dependent on how hard a person is working. For example, if you are working hard, this would cause an increase in all these values. However, not all of these values can continue to increase the same amount for the same amount of time and at the same rate. This is because your heart rate is maxed out at 220 minus your age, which is what is known as your maximum heart rate. And stroke volume is maxed out when your heart cannot possibly output any more blood from the heart per contraction. This is apparent in the first graph you can see up here, where you can see the level of stroke volume plateaus around this point here, 125 to 200, and this happens because the heart cannot eject any more blood out per contraction. The test results we can see from the graph for heart rate show that this has increased throughout the whole of the multi-stage fitness test and was the highest at the end of both tests. This is what we expected to see, as in the multi-stage fitness test the intensity gets higher and higher, which therefore means your heart has to beat faster and faster to supply more oxygenated blood around the body. So at the end, your heart will be beating as faster than at the beginning due to the higher intensity. This is due to the fact the heart has to beat faster when exercising in a higher intensity. When submaximally exercising, stroke volume appears to plateau at a certain point on the graph. This is because there is a limit on stroke volume, which is when the heart cannot pump more blood per beat. This is where the graph plateaus and is due to the heart being unable to pump more blood as it is working maximally. The ANS and SA node are in control of heart rate. This is because these take responses from the receptors about how many components to do with the blood. This information is sent to the control center in the medulla oblongata, where the decision to either adjust and change a factor to keep it the same is made. This is then sent to the SA node, which will either continue to contract at the same rate or adjust accordingly. This is how the SA node is crucial to the heart, to how the heart works, and how heart rate is reliant on these factors. Also, during the Wingate test, we would expect to see an increase in heart rate and stroke volume very quickly due to the fact that this is a maximal exercise and is a very quick but very intense exercise, which therefore means heart rate will increase closer towards your maximum heart rate as you are working in that bracket and past the threshold in stroke volume and heart rate of what is normal from when exercising.